Thank you, Chandra. And because it's Mother Language Day, dhanyavadagalu. For setting the stage with that powerful keynote as well. The importance of prevention in cybersecurity cannot be overstated. And that brings us to our next session, one that focuses on understanding the tactics and techniques that attackers use so we can build stronger defenses. When we talk about adversary behavior, one name stands out, MITRE attack. It has revolutionized the way security teams track, analyze, as well as mitigate real-world attack techniques. Today, we have the privilege of hearing and learning from the very person who helped create attack's initial techniques and has spent years advancing its framework. Adam Pennington leads attack at the MITRE Corporation, where he has dedicated years to studying adversary behavior and intelligence gathering. His work has been featured at some of the most prestigious security conferences worldwide, and his research continues to shape the way organizations defend against cyber threats. Join me in welcoming Adam Pennington to SecPod PREVENT 2025, everybody.
You have audio for me? Awesome. Thank you so much for having me here. This is actually my first time ever in India, getting it early yesterday morning, so I'm really thrilled to be here. But the topic that you're talking about today is actually one that resonates with us quite a bit and something we've been talking about ourselves lately. And so I'm going to be getting into attack mitigations, but I'm going to be getting into some other pieces around it first. So I'm not going to go too deep into an introduction. It was a great one. Thank you so much. I've been with MITRE for quite a while now, for the last 16 years. If you haven't heard of MITRE, we are a United States not-for-profit who's been doing work in the public interest for over 60 years. We do a lot of open source and open source-like things that are used globally. If you've ever heard of CVE, that's also MITRE, something we did in the late 90s and still run today. I today run a cybersecurity framework called MITRE Attack. I've been involved with that since 2013 now. And before that, and to some extent during that, I've been working in operations, both in the cyber threat intelligence and in security operations center. And so I've been with Attack and I've been with MITRE both for, well, a long time now. So I'm going to take everybody here on a little bit of a journey in 3 parts. I first want to get into some work on where we might start out as we're thinking about what are the really important things as we're securing our network. What are some of the things that we want to get working before we start getting fancy, before we start even using frameworks like Attack? I'm going to get a bit into some of the details of what Attack is, some of how it relates to where we are here today. And then I'm going to get a bit more advanced and talk about how we might use Attack and take a look at what's our next move, what's next that we can do, looking at mitigations, looking at it through the lens of the Attack framework. So let's start at the beginning. Before I get into fancy frameworks or even really touch Attack, I want to get into 5 things that we all should be doing, and we probably all already know we should be doing, but maybe aren't. And so I sat down with a group of experts who have been working in incident response. They've seen a lot of adversaries break into a lot of networks. And I asked them, if you were telling companies what are a few things that you could do to have stopped most of the intrusions you saw, what would those things be? And I actually got pretty similar answers from a number of them. And they were fairly common techniques. They were things that, again, we know we should be doing, but some of the why we should be doing them, how they relate to more advanced threats, and some of the caveats maybe we haven't thought about so much. And so there's 5 topics, again, which should be fairly familiar, are antivirus, anti-malware, data backup, multi-factor authentication, software updates, and user account management. And so the recommendation for antivirus is to install or enable it wherever possible. Use it across the enterprise. And we've all been told this before, but you might be thinking, this is 2025. Why am I talking about antivirus now? Why am I still talking about it here? Antivirus still can catch lots of basic threats. Most of the things that your enterprise gets infected with are more common threats. They're things that are going around. They're things that people click on. They might be coming in through ads. And antivirus can still have an impact on those. And a lot of those threats that might look benign at first can explode into something much more advanced behind it. They also can sometimes catch more advanced ones. A lot of adversaries use common pieces of malware, things that have been seen before, things antivirus already knows about, and this gives you the opportunity to maybe catch it at click, maybe catch it right at the first instant and stop it. And there hasn't been an excuse for not running antivirus for a number of years now. It used to be that you had to go call Norton or somebody and buy something expensive. Microsoft started just packaging it into copies of Windows, a full-featured antivirus starting in Windows 8, so Defender. You can obviously use lots of other choices, but for not having anything at all, there are options that are probably in your system already. But it needs to not be disabled to be useful. So a lot of us have probably turned it off because it conflicted with some other product or something told us to in order to get something done. But really, really still has a lot of value in working. And the additional recommendation from that group I talked to was to consider allowing cloud protections. So a lot of us are maybe a little bit nervous about files getting submitted to the cloud, comparing. But it can expand our reach and expand the set of threats and expand to very rapidly emerging threats, allowing that cloud protection. The second's another that we all know we should be doing, and that's data backup. The recommendation is ensure all critical data is getting backed up somewhere. And so organizations, may be talking about backups, may have it already on their list, but they usually only get serious about it after there's been a ransomware attack or after they've had system loss and discover that the data is not actually there. Often it's they had a backup and they find out after a ransomware attack that either the adversaries were capable of deleting their backups or they never worked in the first place for the data they cared about. And if you can't afford to back up everything, which data or systems can't you afford to lose? Is it something around your point of sale systems? Is it something around your critical customer data? What is it that, if you lost tomorrow, your business could not function? And, focus there. So, somewhat controversial recommendation that came out of the group I talked to is that don't make perfect the enemy of good. So say you can't do a really fancy backup solution it's going into a good setup. Packing up to something like OneDrive, Dropbox, or Google Drive with multi-factor authentication is still better than nothing. It's not the ideal. Ideally, backups should be off-site, versioned, and restricted from deletion so that ransomware actors can't take them out along with the original copy of the data. A third recommendation is another one that we already know, multi-factor authentication. And so the recommendation is to minimize public-facing assets and add multi-factor authentication to anything that must be public-facing. Okay? So it's kind of impressive how much multi-factor authentication can make life difficult for an adversary. We hear all the time about threats that are involving SIM swapping or social engineering to get people to push that button on their phone saying, yes, leave me alone, it's fine, verify this. But that's still better than not having it there at all, and it's still an extra hurdle. And in a lot of cases, an adversary, if they've got two equal targets, one of them has multi-factor authentication, they'll go after the easier target. And sometimes that is enough to avoid the intrusion. And so the slightly controversial recommendation here is that any form of multi-factor authentication is better than no form of multi-factor authentication. And so we hear a lot of people talk about SMS as a not very good form of multi-factor authentication. And it's true that it's not the best. You have threats like SIM swapping, where people are able to take over SMS devices and other techniques for getting in there. But it's still better than saying, oh, I can't do multi-factor authentication at all. And hardware tokens are the gold standard and generally what you want to be moving towards. The sort of higher level, if you've got that working, consider moving to universal multi-factor authentication, so everywhere, and passwordless authentication, so things like passkeys. So this sounds like a really expensive, really hard thing, but it turns out that it may be something that you've got an easy button in your existing cloud suite already. That this is something that actually with Office and Google Cloud Office suites, you can turn on and be able to roll out through at least a smaller organization pretty quickly. Another one we all know we should be doing already, which is updating our software. And so the recommendation is regularly update operating systems and applications to fully patched versions. And so this one's fairly obvious. Large percentage of the intrusions start at exploiting vulnerabilities in either externally facing systems, in applications, browsers, email systems, somebody clicked or something's coming in from the outside. If you don't have a proactive setup that's able to get everything equally, again, prioritize. Focus on those systems that open up externally facing things. Focus on the end user systems. Focus on the servers that are actually serving up stuff to the public. The places that adversaries are going to be able to reach out and touch. And so, not as controversial, it's still worth patching if you can't do it right away. Say you're working on it, you're trying to get there, you're trying to get to where you've got patches installed the second they come out, but you're not there yet. Still trying for as quickly as you can do is better than not at all. Most exploited vulnerabilities are not 0 days. Adversaries often are using 300 days techniques. They're using 600 days techniques. They're using exploits that came out often a year or two ago. And so trying to get up to date, trying to catch up still has value. And ideally, you should be updating everything immediately and know the state of your software inventory and know what the patch state is across your environment so that you know what's vulnerable if there's an intrusion or an attempt going around. Finally, user account management. This is maybe the one that is lost a little bit more than the rest of these, which is to restrict users and admins to least privileges they need and enable conditional access policies. Ransomware actors have been very frequently taking advantage of overly broad accesses. They're taking advantage of every single desktop and environment having admin for user, being able to get into those, and using those to encrypt and erase data. It goes without saying that not all users are admins or need to be admins. And even your admins don't need access to everything. So restrict what those accounts have access to just what that particular admin or that particular environment needs. This is another one where you might actually discover that there are some easy buttons out there that you might not have tried yet. So in Microsoft environment, for example, there's a security defaults that appears in Entra that you may be able to turn on and actually get some conditional access policies for free out of. And so ideally, admin accounts should require extra hoops to use. They should have extra authentication steps, extra ways of ensuring that they were the right person. And all accounts should have access based on identity conditions, looking at what country is this coming from? Is this the right IP range? Is this matching up with what this user is supposed to be? Okay, so that's sort of the basics and things that we know we should be doing, but a little bit of how those fit into a lot of the more advanced intrusions that we've been seeing. But to each of those, I've had these numbers that I haven't been commenting on in the titles. So M1049, M1043, M1032, M1051, M1018. So what's up with all these random numbers that I've been scattering across these slides? Well, these are all MITRE ATT&CK mitigations. And so each of these are mitigations that are described in something called the MITRE ATT&CK framework. What is MITRE ATT&CK? So show of hands, how many of you have heard of ATT&CK before? Okay, pretty good percentage. And that's sort of around what we find most places we go these days, that it's been around. But some people not in the know, and there's also different level of detail. So I'm not going to do a really deep dive with most people having heard of it and a bit of it, but I'm going to get us all on the same page and go into a few of the details that I'm going to be leveraging. So the way we think about and we talk about attack is as a knowledge base of adversary behavior. So it's like an encyclopedia of things that malicious actors have done in the real world. It's based on real world observables, so not things that just a red team has done, not things that we know are possible, but things that actual adversaries have done in the wild maliciously. It's free, open, and globally accessible. It's just as usable here in India as it is in the United States, and there are no license fees. It's something we put out there as open source. It's often used as a common language. So a lot of different companies and governments use attack in order to talk about behaviors as a common way of saying, this adversary did this particular activity. And it's used, again, globally in that fashion. Finally, it's community driven. So I talk about it as open source, and the way that we know that adversaries have done these activities is that the community comes to us. We get pings all the time from people saying, hey, you're missing this thing. I just saw it last week. And we say, okay, well, thank you for letting us know. We'll now get that into our next release. And so attack is constantly updated. We put out a new version of attack every 6 months based on what the community has told us they've seen in that time frame. And so we talk about it as a knowledge base of behaviors. And why behaviors and sort of what is that space? We like to use this diagram that a friend of mine named David Bianco created that he calls the pyramid of pain. So the idea of the pyramid is that it goes up through different levels of how much pain is it for an adversary if we block or detect a particular indicator of theirs. And to start at the bottom, we have hash values. If I'm watching for one hash of one binary, all an adversary has to do is add a single bit to the end of that file, and the hash is completely different now, at least if you have a good hash. As we move up the scale, we get to things that are easier and easier for an adversary to change. So something like an IP address. I can get a new IP, I can change up stuff at my cloud provider anytime I want to. Something like a domain name. I can always register a new domain anytime I want. But it does work up and get harder and harder for an adversary. If we start taking out their protocols of the different tools they use, it might be hard for them to change that up. They are pretty tied to some of their tools. But David's belief, and we're here with him, is the hardest thing for an adversary to change is their tactics, techniques, and procedures, or behaviors. Adversaries are creatures of habit just like us. They get up in the morning, they brush their teeth, they go to work, and they operate in networks a lot of the same way. They've got patterns of activity that they do over and over again with how they move through a network, how they get in. And if we're able to target those particular behaviors, we can have a powerful way of preventing them that can be really painful and tough for an adversary to get around. And that's the space that attack lives in. We talk about those behaviors, and we also talk about things you might be able to do about each of them. So if you've seen an attack before, this is probably the view you might have seen. We call it the matrix. And so I don't expect you to be able to read it. It's super small font, just more looking at the shape. So along the top of the matrix, we have what we call tactics. That's not going to work for me. It's the row at the top, starting with initial access, which is an adversary trying to get into my network, to impact, an adversary trying to deny or degrade access to resources in my network. And so along the way, it works through different general behaviors that an adversary goes through over the scope of an intrusion. Now, an adversary won't do all of these in a given intrusion. They might, and they're also not technically in order. So an adversary might go back and forth across the top, but these are the general technical goals that an adversary has for a part of an intrusion. Under each of these, we have what we call techniques. These are how the goals are achieved. And so this is getting into a lot more specifics. So instead of something like initial access, we might have phishing. An adversary is sending you a malicious email. Or in impact, we might have denial of service. So an adversary is sending excess traffic and trying to take down one of our systems. And so we added another level to this back in 2020. We were starting to have too many techniques. This was getting even more unreadable than it is on the screen now. We couldn't fit it on a PowerPoint slide anymore. Real problems. And so we added another level of detail, which is sub-techniques. And this lets us talk about each of these activities in a lot of cases in more detail. So instead of initial access, instead of phishing, we now have spear phishing attachment. So an adversary is trying to send a malicious document or object attached to an email. And so I've got tactics, I've got techniques. So you might not be surprised that the final level is procedures. And so this is within each of these techniques and sub-techniques, getting into the ways that specific adversaries have accomplished them. Now, this can be really valuable information for tuning our defenses. So if I'm nervous about a particular adversary, it can be something where I look for the particular method that they're using, or even just as I want examples of real-world ways this has been done in order to make sure my defenses are actually aligned with the real world. So instead of spear phishing attachment, we might have detail like APT12 has sent emails with malicious Office documents and PDFs attached. And so that gives us more of a signature, more of a set of things that we might be able to think about, might be able to focus on. Within each of those techniques, we have a lot more detail. And so techniques and sub-techniques have the same fields. They start with a description of the behavior from an adversary point of view. So what is it they're doing? How would they normally accomplish it? What are some of the variations on it? And so just getting into the detail that both a defender or somebody like a red team would need in order to be able to actually stop this. We have metadata. And so up at the top of this, we have technique IDs. This is that T1566.001. When I talked about attack as a common language, this is often used in reporting. A lot of industry calls them T-codes. And so we see reports coming out of a lot of different governments that use these, as well as a lot of different cybersecurity providers, when they write reports talking about adversaries, are using these technique IDs. We get into what tactic or tactics a technique could be a part of, and techniques can be a part of multiple tactics. We talk about what platforms that technique's possible on. So things like you could do this activity on a lot of different operating systems. We also talk about cloud platforms, network infrastructure devices, wide variety of spaces. And then various metadata based on the individual tactic. So the theme today, we also talk about mitigations. And so what are the ways that we might be able to prevent or mitigate the impact of a particular technique actually happening against our network? So what changes to our security posture could we have taken for this to have a much lower impact and not hit us quite as hard? And so those mitigation numbers that I started out with are over here on the left side, those 1049, et cetera. I'm not going to be talking about them today, but we also get a lot into detections. And so these are how you might be able to implement on a SIM ways of actually detecting this individual activity from happening. And so we've added a lot of analytics to this. We have pseudocode that you might be able to put into your SIM without a lot of changes. And we're adding more and more advice for defenders on how to implement these individual detection techniques. And so we've got the procedures that I talked about earlier. These are the examples of how different adversaries have done this. And we have tons and tons of references. Attack has over 3,500 references in it going back to the original source information we used. We want to show our work. We want you to be able to check us and see, is this what you thought we were saying? Do you agree with us? And so especially for these procedures, you can go back and take a look at open source, publicly available threat intelligence information to validate each and everything that we're saying across over 100 different groups. Speaking of groups, so we also keep track of threat groups in attack. This is over 100 different state actors, ransomware actors, high-end crime actors. We get into a name based on something that industry has called them, a description based on this open source, publicly available threat intelligence information, a group ID that's starting to be used more widely, and then what we call associated group descriptions. And so if you've read threat reporting from a lot of different companies, you'll notice that different companies call similar or the same actors by their own company's name. In the case of an actor like APT29, these guys have a lot of names. So we might be calling them APT29. They're also known as Cozy Bear. They're also known as the Dukes. Microsoft used to call them Yttrium. They also used to call them Nobelium. And so it's getting into the different names that you can go out there and cluster from this activity. And then we've got the flip side of procedures, and that's the techniques used by each of these groups. I'm not going to be really digging into it today, but we also keep track of different pieces of malicious software. And so we have over 600 different pieces of adversary software. We're keeping track of what attack techniques could be done with them. And again, as with all of this information, we're keeping track of the references so you can go back to the source. So what are people doing with this? So probably the most common historic activity with attack is to map out and create detections. So looking at sort of what in a SIM is being already watched for, being able to plan out the future, being able to write analytics. Second most common is threat intelligence. I'm going to be leveraging that a bit in the next piece, but looking at what do we know about adversaries, how do my adversaries compare, what am I worried about, and being able to look at a picture for a particular threat actor. Next most common probably is adversary emulation. That's what attack was originally created for. We actually created it as a red teaming tool. We wanted to be able to create a picture of what a real-world threat actor did, create a plan, and then be able to act it out, see how that worked against a real network. And this is a really common use case today. A lot of red teams use attack. A lot of red teams are required to use attack. And so this is able to keep into an adversary profile rather than just sort of playtime. And finally, and this is where mitigations often come into the picture, is assessment and engineering. This is sort of pulling the pieces together, looking at what can I detect, what do I know about my adversaries, how do those match up, what do my red teams see, How does that go? And using it to plan out my overall defenses and decide what it is I want to mitigate. So that's attack. That's some specific mitigations from it. But how do we pick our next move? How do we pick the mitigations that I want to do in my network next, once I've gotten some of these pieces working? So let's start with, what do those earlier mitigations potentially get us? And again, I know the text on this is unreadable. I'm just looking at the shape of the picture. So these blue squares are each a technique that could potentially be stopped by those 5 mitigations I talked about at the beginning. And that's not bad. You know, five things we know we should be doing today, and I've got blue on a lot of techniques. Now, there are caveats to that. You know, did I implement the mitigation in a way that actually aligns with that individual technique? Maybe, maybe not. You know, is the technique being done in an interesting way that gets around a particular mitigation? It could be. And so there are shades in here, but this is what it potentially looks like from the activity that we already did. And so how do we pick our next technique to mitigate? How do we pick sort of the starting point to kick off to get into some more mitigations? I'm going to talk through 3 different methodologies for looking at our world, looking at our environments, and deciding where to go next. And so it's just suggestions, though. Attack is, again, is something that's out there freely available. You can do whatever you want with it. We're okay with that. But so I'm going to talk about a tool-centric approach, looking at, what is it that your current tools can accomplish, and using those as starting points. Starting from threat intelligence, looking at what our adversaries are doing and planning out from there, using it as a way to come up with ideas and figure out where we want to go next. And finally, I'll talk about a red team approach. So where are my red teamers succeeding, and using that as a way to plan what comes next. And then out of this, we'll be able to implement mitigations that align with our priorities. Let's start with a tool approach. So, sounds easy. Determine what your current tools might accomplish. So a lot of us have existing tools in our environment where we're not using their full capabilities. It's stuff that we've already paid for that might have features or configurations that we haven't taken advantage of that may get us a lot more traction against real adversary threats. And so you might use as a way of ideas actually digging into the mitigations directly, so taking a look at sort of the broader list. And so we have, I just showed 5 earlier. There's dozens and dozens of mitigations currently in attack that get into across a broad set of types of tools. And so, taking a look at what it is that we can do. And so, just as sort of cementing this from where I was talking about earlier, some of the starting mitigations are ones that I was already getting into. And so it's getting into which techniques your current configuration can prevent. So looking at across your tooling, doing a poll, picking it all and pulling it together. And so that sounds easy, but it actually can be a relatively complicated process to pull together this information. We probably don't have it at our fingertips. But a couple of less obvious non-technological methods that you might consider trying. And so there are tools that may be able to bring this together, but some things to consider that sometimes get left off the table. One is read the documents, read the manual. Sounds obvious. A lot of us haven't done this for our really expensive cybersecurity tools. We've never sort of gone through and seen what all the features are. And when we have members of my team have gone out and done an assessment for an organization, this actually is often a big piece of it, taking the documentation for the tools that people have already bought and figuring out what features are there. Another one that, again, we often see people not actually doing, even though it's kind of obvious, is to ask the vendor. So especially the vendor sales team is probably very happy to tell you the features that the tool could do. They want you to continue buying the license next year. And so they're motivated to help you understand what is it that their tool could do that you already have. And so from there, consider the changes that might help you. Should you change the configurations of an existing tool? Are there features you can turn on that will directly impact some of these mitigations, some of these techniques? Or is it time to actually buy something new? Is it time to spend some money? The second approach I'm going to talk about is a threat intelligence approach. Choose a threat group you care about. Well, how on earth do I do that? I don't know threat groups. I don't talk to these guys. I don't have a threat intel team. So maybe start with looking at a group that targets organizations like yours. Something that we often see is that adversaries will pick on particular nations, particular industries, and often stick to those areas. So if you have an organization in the past has targeted Indian companies, and exclusively Indian companies, well, maybe they're a good place to look. Or maybe it's a manufacturing sector, maybe it's retail. And so you find specialities with a lot of the adversaries out there that might give you a place to start, a place to at least figure out where I might want to look first. Then that adversary must not actually go after that industry, and that's not the case. However, Thailand's CERT, or what's now called the Electronic Transactions Development Agency, has had their threat group cards website, Threat Actor Encyclopedia, that they've had going for a long time now, gathering, in a lot of cases, similar data to us, open source, publicly available threat intelligence information, as well as other sources they've been able to bring together. They have their own way of sort of looking across different adversary names, looking at different companies. But something really valuable they have out there for free, and the free part's a little unusual in this space. This is often only in paid threat intelligence feeds, is that you can search by industry and country. And similar to us, they back up their data with references. So this is stuff where you can actually look and see in a lot of cases where exactly they got that data from. So say I'm in aerospace, looking at the threat groups that target aerospace, target companies like mine or my particular part of the world. So once I've got a group, take a look at their attack techniques. So we have those over 100 groups in attack. If you're finding it in the Thai database, there's a good chance that we have it too. We've mapped a lot of reports to it. We're looking at the various techniques and start building these up. And prioritize mitigating them. So if I have an adversary that I care about that is doing particular techniques, that could be a really good starting point. That could be, what it is I want to do first. Now, it's not going to be necessarily everything I want to do. The data is not going to include everything an adversary's ever done. It's not going to include what they do next week. But it is going to include what we know they're already doing. And so, it can be a way to prioritize instead of this giant universe of stuff to do. So another recommendation from that expert group that I talked to in pulling together those mitigations was to focus on tactics and techniques used early in the intrusion cycle. And this is going backwards a little bit. So one of the things with attack is it's getting into later phases of the kill chain, looking at techniques that adversaries are doing long after they've gotten in. But there still is some value in stopping an intrusion early. Again, relatively obvious statement, but it's not necessarily something we're always thinking about. And in attack terms, this is mitigating techniques in initial access, execution, discovery, persistence, and credential access. And so these are activities that often happen in the first couple minutes of an intrusion and not sort of in the later, maybe weeks or months down the line. So I've got one group I care about. I figured out their techniques. Why don't I do multiple groups? And so, another eye chart, another where the text isn't readable, just looking at the colors and the shape here. And so I've taken two groups that a lot of places have to worry about, APT 28 and APT 29. And so yellow is techniques seen from just APT 28. Blue is techniques we've seen from just APT 29, and green is the overlap. And so if this is what I'm looking for, maybe I've piled a bunch more groups than this, well, those hotspots can be priorities. They can be starting points. Again, they're not going to be everything that I need to worry about. They're not going to be everything that a group could possibly do, but they give me a way to prioritize and be able to start somewhere instead of putting my hands up and it's just too much stuff. Finally is a red team approach. So if you have the resources, you think you know what your tools can do, you think you know what you've mitigated and what techniques you're going to prevent, bring in a red team to see if those actually work, find the gaps. And so have the red team go after the specific things that you think you've already taken care of. And so maybe focus them on an adversary emulation approach. Make them go down particular paths that align well with what you think you're succeeding on. And so MITRE has published some resources in the space that are free, that you can use them however you want. A related organization to us called the Center for Threat Informed Defense. They're actually who referred me over to here in the first place, how I ended up here. Has created a number of adversary emulation plans. And so these pick out particular adversaries from the MITRE attack framework, groups that we've published, and create playbooks that you or your red team can use to follow. And they've written some open source tools that you can use to try out techniques that particular threat groups that might be of real interest have used. And this is across ransomware, this is across state actors, and gets into a bunch of different areas. The original creator of Attack, Blake Strom, created another project called Caldera. Caldera is an automated red teaming framework that we publish as open source. You can get it out on GitHub. It's available for free. It doesn't have all the full features you're going to get from paying lots of money for a breach and attack simulator, but it could be a way to get started. And again, there is some things that are nice to being free. Another one comes from our friends at Red Canary. Red Canary has gone through and worked with a broad open source community of their own to create something called Atomic Red Team. Atomic Red Team is what they call atomic tests. So it takes individual techniques in attack and gives you small commands or small tools that you might be able to do to replicate that technique. And so you can see, okay, I thought that I had mitigated this technique. Does it still work on my network? Find out if it actually works. And then prioritize based on what the red team saw, what worked successfully, work collaboratively with them. And so finally, once I've built up this list of techniques, the important thing to do is actually to implement the mitigations from them. So if I get into these individual techniques, the mitigations in them not only list the general mitigations, but a description of the configuration of the mitigation that could have an impact on that particular technique, and potentially some suggestions for implementation, as well as why that mitigation might actually work. And so something like application isolation and sandboxing, getting into how that actually relates to drive-by compromise, getting into things like browser sandboxes, pieces around it, and being able to actually stop those individual methods. And so you build up, work through, and start to be able to prevent the adversaries from operating in your environment. So a couple takeaways from the journey I've been through today. To start with, some of the mitigations we already knew we should be doing. We knew we should be doing data backup. We probably know we should be running antivirus. Can have more impact even today than we might realize. That these still align with things that can stop advanced actors as well as just some of the crud that is around on the internet. And so these can have a really big impact if they get in the way, if they actually stop an ongoing intrusion. There are a lot of small steps that we can be taking that can add up to large security improvements. So we can do these individual mitigations one at a time, cover a technique at a time. And as we're doing that, we're building up. We can have a large impact and large security improvements as we go. And then there's more we can do beyond that. We can always improve our defenses as resources allow. We can keep building up additional mitigations. And maybe if, once we have our mitigations really strongly in place, it might be time to start looking at fancier things like SIMs and defenses and detections. And so that's me. Feel free to reach out to us at Attack through any of our different mechanisms. We're out there on a number of the social medias. We're focusing on Blue Sky these days. And then if you see something out there that an adversary is doing and we're missing it in Attack, attack@MITRE.org is how we get started with all those contributions. And so timer says I have 5 seconds. So I appreciate your time and thank you very much.